Okay, so welcome to the TIW Day 2 cam overview. What I want to do is we're just going to go over the cam I have made for this part. Um, I'm not going to give you necessarily all the answers and all of the buttons to press. You should get yourself comfortable with Fusion. Um, but this is to give you kind of a starting off point for this part. So this part is done in two setups. Um, the top, I am doing basically the pocket all the way through. Um, nice facing, nice chamfers, profile around the edge. And then I am flipping the part over, facing it off, and then doing the drill and counterbore. Um, so to start off in setup one, I go to edit this guy. So the way I like to do stock is fixed size blocks because usually I know how big the stock is. You presumably will as well. But one thing that's important is giving it a little bit of an offset on the width and depth, um, unless you measured it super precisely. This is so that if the block is a little longer than you would want it to be, you don't end up in a situation where the tool suddenly is cutting off more material than it expects. Another important thing here, so the model position. Right now, the part is closer to the top than the bottom, and that's intentional. This is so that I can do all of the contouring around the side of the part, flip the part over, and then just face it off. If this part was lower and I did some of the contouring on the other side of the part, any misalignment in how I indicate my origin, so if I flip it over and my edge finder's a little off on this side, it'll be super obvious on the side face, and you'll see what you might hear me call a layer line, even though it has nothing to do with 3D printing, but there'll be kind of a pretty visible shift there. But the way I'm doing that and the reason I chose this value, so model position, offset from bottom. So then you just type in your offset here. Um, in general, you want at least 1/8 of an inch of your part in the vise. Um, so you might think, oh, just set this to 1/8. Well, then you're basically setting yourself up to rub against the top of the vise. So give yourself some good clearance here. Basically, I took as much as I was comfortable with. I still wanted to take a bit off the top, so I guaranteed a nice finish on the top of the part. But you do have some freedom here. This guy could probably go, well, okay, up to 1/4 of an inch and still be okay, and you have lots of clearance on the vise. Um, all right, another thing here. So if I go to um, the setup here, another interesting thing here is my origin. So my origin is at the center of the part, or center of the stock. So the reason I do this is so that I know I'm taking basically an even cut on both sides. Um, it does mean you have to indicate all four sides of the block, which takes extra time. So if you want to be lazy, you can definitely get away for this part, putting your origin in, the top left or one of the corners and just indicating off of two faces. This is just, in my opinion, better practice if you have a probe or something that can indicate really fast. Um, yeah, so we're going to go into the actual cutting operations here. So one tough thing about this part is you have this deep pocket that's got kind of a tight radius. And if you remember in your day one training, there are a few different types of lead-ins, right? There is the helical, where the tool basically moves in a spiral. There's a plunge where you just send it with the end mill. Um, and there is a ramp where the end mill goes down diagonally. Um, for this one, I opted to do a pre-drill method. So I go to this pocket here and I drill with a 1/4 inch, and then drill with a 1/2 inch drill. The reason I step up is because the 1/2 inch drill kind of struggles on the 440. But we, yeah, this is the very first thing I do with the part. This is so I have somewhere for my end mill to go through and start cutting the pocket. The next thing I do, and in general, um, the first thing you usually do, if you're not doing something like this where you're gonna scuff up the top of the part, is a face. Um, so for this guy, I am using a 1/2 inch 4 flute HSS uncoated end mill. Um, so in general for HSS, I recommend 2 thou feet per tooth. Um, yeah. And for this one, I definitely was pushing the machine a little bit, doing that at about 25 inches a minute, but it did work out fine. The one thing you need to keep in mind, though, is the limit on your feed rate is your spindle horsepower. And there's a few things that go into that. Go over to our passes. One of those is your step over. So that's how much the tool radius is engaged. That's 0.15 here. And the other is your step down. I enabled multiple depths here because I like to control the step down. Um, you don't want to end up in a situation where you accidentally take off too much material, stall the spindle. Step down here is 50 thou. So what I did to pick these numbers is I put them both into FS Wizard, as well as all of my tool parameters, and set my desired feed per tooth, and it gives you a spindle horsepower. For the Tormach, technically the spindle is capable of 0.75 horsepower, but the horsepower that the spindle can spit out is dependent on the spindle RPM, and the machine's a little old, and it can stall on horsepowers lower than you would expect. So I usually don't go more than 0.1 horsepower. But yeah, so yeah, this guy's just a pretty normal facing operation, crossing up and down the part. Um, Once that's done, we get into the actual meat of the material removal. So for the adaptive here, in general, there's like 2 different strategies people use for adaptives. The first is using more of the tool radius but smaller step down. Um, and the other is using as much of the tool length as you can, but very little of the tool radius. I prefer using as much of the tool length as possible. Um, you get, in my opinion, better better tool engagement, and from what I understand, the chips are able to take out more heat than like a conventional strategy. Um, so for this again, I am targeting again about 2 thou feet per tooth. Um, that is again just a number that works really well on these end mills, and that the machine can handle. Um, yeah. So the step over and step down is a little different for this one. Um, so I am using the full flute length as my maximum roughing step down. Um, but I am dropping down the radial engagement to 10 thou. Um, Basically, as you increase this guy, you increase horsepower. So this is kept pretty low. The part was pretty happy when it was low. The other thing here, so I come in later after doing adaptives to do a finishing contour. And so I have the stock to leave option turned on, with a 10 thou radial stock to leave. That leaves me some material that I can come back in, and do a clean finishing pass, so that the part looks really good. Um, Another important thing here, so setting the bottom height of this adaptive, I'm referencing off the model bottom, but I'm referencing slightly below it, so that when I flip the part and have to face off basically what is right now the bottom half, um, I basically have some wiggle room in how deep that toolpath can be, and so that the depth overlaps a little, so I'm certain I'm getting rid of that material and not left with like a weird thin little flap on the edge. But if you notice this adaptive, so for the most part, it's just zooming around the edges of the part. Um, but after it gets to that, it gets to this part where it's just going forever and ever and ever, cutting out this slot. Um, there's a better way to do this. Let's leave it at that. Um, the other thing here is I'm not touching this pocket in the adaptive yet. Just because this pocket is particularly nerve-wracking, because there's not good chip clearance. But I am holding off on the pocket. So the next thing I'm doing here is I am just finishing these faces. I'm using a horizontal to do this. What the horizontal does is it catches this face, but as a consequence of touching this face, it also runs along the edges. After that, I do my finishing contour around the whole part. So for this, the tooth out feed per tooth does give a very good surface finish, so you don't really need to drop the cutting feed rate. Basically the tooth out feed per tooth is already a good finishing feed rate, or sorry, a good finishing chip load. But run this contour separately so that all of the chips can get cleared out, and so it's not recutting chips during that finishing pass. One thing to note here, if I go to passes, if I go to heights, this also has that little height offset there again. Again, that's just so that when I chop off the top face, there isn't like a weird thin little guy left. The other thing, if I go to passes, so this finishing overlap option, this adds, if you look at the toolpath, so the tool enters at this this red guy, goes around the part and then leaves up the yellow guy. So there's this overlap here, and that is if you only go up to where you started cutting, basically you have a weird mark on the side of the part, and this helps it have kind of a continuous surface finish on this. Okay, pocket adaptive. So, this one basically, same-ish feed per tooth, not going crazy there. I did drop down the maximum roughing step down, just because this pocket is theoretically not great for chip clearance. You could probably get away with doing the full pocket in one step down. But the important thing here is this lead-in. So we drilled this hole at the very beginning. We want to actually use it. And the way to do that is with a pre-drill position. This was defined in a sketch. If you switched to design, I made a sketch, added the point where I wanted the pre-drill, put the pre-drill at that point, and then selected that as my pre-drill position. Other than that, yeah, end mill goes down where it was drilled, and then it spends a while hogging out this material. There's again another finishing contour here. This should be, you should give yourself again a little finishing overlap here if you're doing this style. But yeah, so those are all the like main roughing and finishing operations. The one thing that is not finished yet is the top face, and for that we use a fly cutter. The fly cutter gives a very good surface finish very easily. It's also pretty fast at just covering this big area. If we go to this guy, so for this fly cutter, you want to spin it fast enough that the spindle is in a happy speed. If you spin the spindle too slow, it won't be able to output enough torque or horsepower. so you do need to spin it fast enough. This does just get a little scary as you really crank the RPM. So I would not spin this guy past 2000 RPM. But yeah, so this cutting feed rate and this feed per tooth, those actually come from a really good video where someone basically took a bunch of aluminum blocks, trial and error until they got a good finish on this fly cutter. That is also another valid way to pick feeds and speeds is what did someone else pick? You just want to make sure that you're also matching up your step down and your step over. For this one, because the fly cutter is larger than the part, I set a 3-inch step over so it does the whole thing in one go. It doesn't need to take multiple passes here. Yeah, so there's that. One thing, this is a pretty big toolpath, so just make sure you got room on the machine for it. Spoiler alert, you do for this one. After this is a chamfer. So note on chamfers, they don't work really well if you already chamfered the model and then imported it. The Fusion chamfer toolpath kind of freaks out. But if we go up to this, some important settings here. So I targeted 1000 feet per tooth because this is like definitely very much a finishing pass. But I want the RPM basically as fast as possible because this is a small tool. Under geometry, I've selected everything I want to chamfer. I haven't drilled these holes yet, so I'm not going to touch them. That is a very easy mistake to make is see this and then accidentally chamfer it and you just plunge the chamfer into the part. But the important thing here under passes, you have your chamfer settings. I picked a 0.015 chamfer width. Sometimes you have a good reason for a specific one. I picked this because it's enough to deeper and kind of be visible, but it's not huge. This also has a finishing overlap. Again, I recommend using it. Yeah, and there's that. So on to setup 2. So whenever you're adding an additional setup in Fusion, it is the same as you added the first. You just have some new and exciting options. So if we go to this one, so same machine as before. I'll go over the origin after this. So stock. No longer am I defining a box. I now have from preceding setup. Basically, I'm going to keep machining what I've already machined. The other neat thing here is I can do is continue rest machining, and it will remember how much I've cut off. So if you don't check this, it just thinks you got the box. If you do check this, it also includes all the material you've already cut off. This is handy when you're doing adaptives because adaptives will, they won't waste their time cutting air. So you want to keep this checked so that it remembers what has already been cut. Okay. On to the work coordinate system. So this one, there are 2 interesting things happening. So first of all, my Z is not at the top of the part. So this is kind of a roundabout way of getting a really good tolerance on your height because the tolerance of your block is going to be a little slanted. The height isn't going to be super precise. So if I measured off of this height and then use that to decide how much to cut off, I don't actually know how tall this height is. And so I could end up with a pretty sizable disconnect. What I do know is this face is sitting on the parallel. And so my height, if I offset from the parallel, will be good. So what I have done here is I've added this plane that represents the height of the vise, and I've used that as my 0. Again, this is something you just go over to design, add a plane, add a sketch with a point. But this this lets me get some precision. You probably don't necessarily need to go crazy on this all the time for every part. But this is, if you care about this part being exactly as tall as it needs to be, this is a good way to eliminate that error. It does mean you're touching off on the vise, which has its own like weirdness. If you're using the height setting block, then that is a little awkward to fit on that part of the vise. So also keep in mind how you can actually indicate. The easiest option here, of course, would just be touch off on the top of the stock. The other interesting thing here is the origin of this setup is at the center of this pocket. So this is so that I get my holes tolerant well relative to the pocket. So say theoretically I had a part that like fit in the pocket and then had the matching threads for these bolt holes. I would want the relationship, the distance between the pocket and the bolt holes to be pretty reasonable and pretty correct. If I reference X and Y off of the kind of stock, then, the stock faces aren't flat and parallel, right? I haven't touched them with the machine yet, but I know that these faces are really, really good because I went at them with the contour. And again, this is also at the center of the pocket, so that you can pretty much average any error you have in those faces. Again, so this means you have to indicate off of 4 faces. That's really time consuming with an edge finder. You could probably do just as well indicating off of this face and this face. You could probably do perfectly okay in terms of the part getting made if you indicate off of this corner here. Kind of up to you, kind of up to how much you care about the precision at which these holes are placed. But just a thing to keep in mind when you're making your own parts. Yeah. So this guy starts out with the face again. Same cutting parameters as the first one. And it leaves a little offset to go at with the fly cutter. So we generate that guy, and already the part's basically almost done. The next thing here is the drilling. So I like to do drilling before I finish any faces. That's because drilling will leave a burr. So we have, first of all, drilling all the way down with our 1/8 drill bit to grab these holes. Drilling. I didn't mention this for the other ones, but this also applies. You need to be careful about drilling. So for small drill bits, you generally want to crank the spindle RPM. For big drill bits, you want the spindle RPM fast enough so that you're on a good part of the kind of torque curve of the spindle. With drilling holes, the safest option is not to just send the bit all the way through. If you get chips stuck, you can break the bit or stall the spindle. So if you go to cycle, you can use something called pecking. So if you select deep drilling full retract, and we hit OK here, and I simulate this guy, the drill bit it'll jump up and down as it goes. And this is so that the chips get evacuated. It takes longer. You're just, sitting here watching the drill go. But it is a very safe option. With all these, you can try and push them as you get more comfortable in the CNC, but your goal is to make a part, not necessarily make it the fastest. The other thing here is feeds and speeds matter for drill bits. FS Wizard can do these. Same kind of rules apply. Don't trust the horsepower output. Don't choose feeds and speeds for 0.75 horsepower. You will stall the spindle or break the bit. Be a little conservative there. Don't go above 0.1. Yeah. So next thing here is the counterbore. Counterbore is a little tricky. So we have this scenario where again, we need a lead in. And you have basically two good options here. You can't really ramp in. You don't have room to do a diagonal. You could do a helical. It would be a very small helical though, and the tool would probably get pretty mad. Um, the option I picked, and that I also recommend you pick for this, is because the center of this hole is carved out. The end mill actually does a pretty good job of just plunging into the counterbore. So that is what I did. I did make sure in the plunge feed rate to drop that down because I don't want to plunge fast. That would be scary. But again, for this one, target around 2,000 feet per tooth with a fairly, I guess this is a pretty high optimal load for the tool diameter. But this was kind of checked in FS Wizard again to make sure my horsepower wasn't too crazy. But this is also using the full tool length. I think it'd be a little ridiculous to step down in this hole. For small end mills, be careful about this optimal load. You can pretty quickly break an end mill. Usually for big tools, you'll stall the spindle first. For small tools, the end mill goes bye-bye. So, yeah, as you can see, plunges down, and then it does a bunch of little tiny circles to simulate this. That'll make more sense. Yeah. Let's slow it down so it actually, yeah, plunges down through the hole and then shakes around kind of a bit. For the counterbores, I didn't add a finishing contour. I'm okay with a subpar surface finish on the counterbore. You're not going to see the surface of the counterbore because there's going to be a bolt in it, in theory. Next thing here, another fly cutter pass to make this face nice and shiny. Same deal as before. And last is the chamfer. For small holes like this, you need to be careful when you're chamfering, because if the chamfer is too wide or if the tip offset is too deep, you could end up with a scenario where the tip of the chamfer hits this, which won't be awesome. Yeah, so these are all just my recommendations to you. All of these feeds and speeds, like this cam is what was run on the machine when I made this part. But there are always improvements here. You can also save yourself a lot of time by just indicating off at the corner. Yeah, so again, always simulate your program before you run it on the machine. And this will also just give you an overview of all the cuts one more time. But you want to check that you aren't, one, just crashing an end mill into something that already has material. The simulate will check that. And then two, it's also just a good, vibe check. So, we're taking off a very, very gentle amount of material here. I'm okay with that. This, again, you can see the step over is very small. And we're happy with that. If you ran this and the tool was suddenly taking really, really deep cuts radially, you'd be concerned. I'll speed through this because it's going to take forever. But the other thing you can check here, so I have colorization set to comparison. So what you'll see is once it starts doing its finishing passes, it'll turn green as it's within 1 thou. This is a good way to check that you've actually machined all of the features. If you see blue, that is a good indicator you still got material to cut off. And also, you don't want to recut anything that's green. So if this side face was green and then the end mill wandered over and cut it again, it would look pretty nasty. And that's a pretty reasonable thing to check in this simulation. Yeah, so now we're on to the second side here. seems pretty reasonable. There it goes. Um, yeah. And you notice it's fully grabbing all that stuff here. Jill looks good. We're pecking. That's important. It's gonna take forever. There's our counter bore. Fine. Okay. Other thing to notice here, chamfers are gonna be red. Don't freak out. That's because the chamfer has technically less material than the original model had. Um, but looking at this, all of our faces are green. We machined everything. There were no crashes in the simulation. That's like the most important thing is catching crashes. So I'm pretty happy with this. Of course, I'm cheating because I know these toolpaths also worked in real life. Okay, once you're done on your G code, so you do want to make sure your post processor is set up correctly, and I will highlight some things there. But also, um, in your day one training, you probably exported these as each one individual NC program. That results in you running back and forth from the computer or from loading a new file every time, which could be a little annoying. If you set up your post processor correctly, the machine will just pause and let you swap tools. So what I'm going to do is I'm going to create an NC program for the entire setup one. I'm going to call it setup one. I'm going to also name it in Fusion. So this is for when it actually pops up in NC programs. But the important thing here is I believe where is it? Yeah. Optional stop should be checked. That way it actually pauses. Basically just make your settings match mine. That's the more important thing. Save for tracks to G30, and when you're on the machine, you should actually configure the G30. That's important. Which ask about that in your training. They should show you it. But yeah, I think also using M6 is important because that is the tool change command. I don't fully remember. Yeah, make sure you selected the correct machine and the Tormach post processor. But once you post this, it is the full and entire code for the entire everything. And there will be tool changes throughout. See if I can find one without T. Yeah, so like here, it starts a new tool path, says T52, and there's that M6 command. So this will pause the machine. It will say insert T52. So we'll go insert T52, and then you click cycle start, and it will start the T52 cutting. Now here's T22. So this manual tool change should be, I believe, configured per tool. It should be set up correctly in the tool library. Just be ready in case the CNC does something funny. All I'm gonna say. Yeah. So same deal for setup 2. And name it something sensible. Setup 2. So there goes that. Yeah. Another thing to check though is that you're not going to hit the vise. A good way to do that is to check your Z minimum. So this is the closest the tool ever gets to the vise. The pocket does go deeper, but it's in the empty space under the vise, so we're not concerned. So what you should do when you're on the machine is after you zero your tool, jog it over to the side of the vise to your Z minimum and make sure it passes over the vise. And the way to check your Z minimum, there's a few ways. One, you could dig through your G code. There's a lot of Z's here. Two, you could go to your individual operations here, and if you right click, you can hit show toolpath data. And here we have our Z level here, and you can see our C level minimum is negative 0.77. This is basically a nicer way to look at your toolpath. Yeah, it works better for the contour because the contour has relatively little going on. If I popped open this, yeah, it gets a little crazy on the adaptive, but same deal. We know our minimum Z is negative 0.77, so that is what we can jog the end mill down to check that it doesn't punch into the vise. Yeah. Other last minute detail things, sanity check. Make sure your units are inches. Machine is in inches. Um, there's such thing as metric G code. Um, it's a really good way to crash the machine if you mix that up. Um, but yeah, good luck with your day 2 part cam. Feel free to reference this video. Ideally, you are not going through and trying to copy everything perfectly. Think through what makes sense to you. But this is a more complicated part than the day 1 training, so it's okay to do that if you really need. Um, cool. Thank you for watching. Hopefully, see you at day 2 training.